on dilations. So our next transformation is the only one of our transformations that is not a congruence transformation. The rest of our transformations always resulted in an image that was the same size and shape as the pre-image. This one, though, this is a figure. The figure is expanded or reduced. The figure expands or reduces with respect to a fixed point. Expands or reduces with respect to a fixed point. So the transformation looks like this, where we're going to take each xy coordinate, and if we're expanding, if our fixed point is the origin, we're going to simply multiply our x and our y by the same scale factor k. So k is called the scale factor, and if k is bigger than 1, then that's going to be an expansion. And if k is between 0 and 1, that's going to be a reduction. Okay? Both of these are dilations. Now, when we say dilation in ordinary speech, we usually mean an expansion, but dilation in this context refers to either an expansion or a reduction. So we can tell which it is by how big our scale factor is. So here, where we have, we want to draw the image after a dilation having a scale factor of 2. We're going to take each of these points, and the notation is the same. We still use an A prime, a B prime, and a C prime, and we put our coordinate after this. But we're going to multiply by 2 each of our coordinates. So 2 times 2 is 4, 3 times 2 is 6, 3 times 2 is 6, 1 times 2 is 2, 1 times 2 is 2, and 2 times 2 is 4. So we'll plot those new points, 4, 6, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. There's our A prime. B prime at 6, 2, 1, 2, 3, 4, 5, 6, 1, 2. There's B prime, and C will be at 2, 1, 2, 3, 4. C prime. And when we connect our points, notice that the corresponding sides to the original figure are no longer the same length. They are now twice the length. Notice AC is that diagonal distance there. You had to go up 1 and over 1. Well, to get from C prime to A prime, we have that diagonal length of, we have to go up 2 and over 2, right? So the corresponding sides are still parallel to each other, but they are not the same size. One nice visual we can use here is if you connect to our point of dilation, the origin. If you put a line through a point on the pre-image and its corresponding point on the image, they make a straight line. You do that with any of those points there. The point on the image and its corresponding point on the pre-image will be in line together. Okay? So notice not only did it get twice as big, but all the points got twice as far away from that point of dilation. So in this example where we're going to perform a dilation with a scale factor of 0.5. So this is our K value, 0.5. M at -6, -4. When we multiply by 0.5, we're going to be at M prime. Times 0.5, that's just dividing by 2, so that's going to be a -3 and a -2. So M prime at -3, -2. Notice that if you draw a line through that point and through its pre-image, you run into the point of dilation there. That's our M prime. We'll do that with the rest of these. A prime multiplied by 0.5, we get -1, -2. T prime at -1, -3. And H prime at -3, -3. Each of those just multiplying by a half. So when we plot A prime, -1, -2, notice just like AM is horizontal, A prime, M prime should also be horizontal. It's just half as long now. and half as close to the point of dilation. T at -1, -3, T prime, and H prime at -3, -3. Notice that each of the corresponding sides is half as long, so like MH was 2, M prime H prime is 1. HT was 4, H prime T prime is 2. So the pre-image and the image are the same shape, but not the same size. Same shape, but not the same size. The words we're going to use for this in geometry are they are similar, not congruent. The corresponding angles are all the same. Notice the M was a right angle, M prime is a right angle. Since C prime, A prime, and A prime, B prime meet at the same angle that AC and AB do, the corresponding angles are still congruent, even though the sides are not. Corresponding sides are. Now, just because the corresponding sides aren't congruent, they're not congruent, as I said earlier, they do still have something to do with the scale factor. They are proportional. So the ratio of the side lengths will still be the same. So the ratio of M prime H prime to MH is the same as the ratio of A prime M prime to AM, right? It's a ratio of, in this case, 1 to 2. So the corresponding sides are not congruent, but they are proportional, and parallel. Okay, we'll take a look at a couple more examples in class together. You can try those on your own, and we'll see what we come up with at the beginning of class. See you next time.